Hey everyone, this is Jacob and Joseph from Roboflow. We're here with some user questions, and we're going to go and just rapid fire them off at Joseph here, and he's going to answer them. So this is the Roboflow computer vision FAQ. So here we go. First question is the image size 416 a magic number? And what would a larger number improve my object detection model?
Okay, I'm going to try to answer each of them in less than 30 seconds.
All right.
So 416 by 416. It's not magic by itself, but it's not necessarily coincidental either. So 416 by 416. When you create a computer vision model, you almost always need to resize the input images to be smaller. It makes your training time happen more quickly and makes the memory constraints less burdensome when you actually go to train your model. Why 416 by 416? Well, it actually makes the math easier in a sense for a lot of what computer vision models assume. Especially in the YOLO family of models, they assume a multiple of 32 for how the convolutions occur under the hood. Now, 416 by 416 was how the original YOLO family of models were introduced. And so that just sort of stuck as a number that now becomes the norm in some senses. I wouldn't go much smaller than 256 by 256 or much bigger than maybe 800 by 800. But in general, that's where 416 by 416 comes from.
Awesome. Okay, here's the next user question. What is the difference between validation and testing? And are the validations images used to build my model?
All right, the difference between training, validation, and testing. So remember, in computer vision, you are trying to train your model to recognize a scenario. And to know how well our model performs, we need to hold some images back to see what's happening. But our model also needs to compare itself to know how it's performing as it's training. That's the origin of the train valid test split. The training data are the images that the model is learning from as the convolutions are happening and as the learning rate gets better. Now, as it's training on those images and learning, it has to compare to some benchmark. So the benchmark it's comparing to during training is the validation set. And so when training happens, you got the training data the model is learning from and compares against the validation set, back and forth. Then when you're finally done with your train and validation, you almost have a final boss. That's the testing set. Mm-hmm. The testing set is almost the holdback that the model should never see until you're ultimately done with maybe a given checkpoint or like almost turning your project in is kind of the way to think about it.
Mm-hmm. Mm-hmm. That's awesome. That's super insightful. Okay, so the next question here. Does YOLO v5, or really any object detection model for that matter, does it see color?
Do models see color? Yes, but they don't have to. So how do models see color? Similar to any digital image representation, there's 3 color channels, RGB, red, green, blue. The way that models see color is by doing convolutions on each of those 3 channels. So there's some number of red pixels in each part of the image, some number of blue, and some number of green. So the convolutions happen on each of those 3 channels, and that's how the model kind of learns about color. Now, you could make your model color insensitive. You could just use one channel of a grayscale channel from 0 to 255, completely black or completely white. But by default, most models assume that you're going to pass 3 color channels. So yes, models see color.
Wow, it's amazing. Okay, so here's kind of a tough one. If I only want to detect certain objects, do I want to label only those objects, or do I need to label all the objects that occur in the scene that my model will be looking at?
Interesting. Yeah, so this depends on how you define your question of what you need to annotate in your images. You need to annotate anything you want your model to know about. So for example, if I had a scene at a soccer game and I want to teach my model to follow the soccer ball and follow soccer players, I would need to annotate the soccer ball in every single image and the players in every single image. If I only annotated the soccer ball in some of my images and the soccer ball and the players in some of my other images, I would be introducing this false information to my model because there'd be images where the players aren't labeled. So you'd basically be telling the model, hey, sometimes ignore these and sometimes don't. So in general, label every instance of the object of interest. We'll put a link in the description of 7 labeling tips that this is one of them, is to label every occurrence of your object. The other 6 are going to be really helpful as well.
Awesome. Okay, so we got another YOLO v5 question here, but I think this is again applicable to all object detection models. So would changing to the medium version of the model as opposed to the small, would that help my model? And why might you want to change the size of the object detection model that you're using?
Yeah, so object detection models kind of come in different sizes, and those sizes are the number of layers that the model includes. So the more layers, generally the more accurate the model can be, but that also, again, comes at a cost. And that cost is not only the time to train, but a small cost in the inference time, and then a big cost in the size of that model. So for example, you mentioned the YOLO family of models. YOLO v5s, the smallest one, is like, 19, 20 megabytes or so for the weights. And on the X, you know how big it is. It's north of 200?
The X, 200 megabytes.
200? Yeah.
250 or
200,
something.
200, north of 250 megabytes. And so that not only takes a longer time to train, but there's only so many, like if you were deploying to the edge, you'd be limited in terms of where you could deploy that thing. So the trade-off is one that we commonly hear, and that is the speed, accuracy, size.
I see. That's awesome. Okay, so here's kind of a Roboflow question, if you will. So let's say I'm using augmentation to increase the size of my data set, and I choose 2 different augmentations. Let's say I choose rotation and I choose brightness. Will Roboflow create 2 images with a rotation augmentation and one with a brightness augmentation, or how does that work?
Yeah, augmentation is extremely important for increasing the quality of your data set. When you choose multiple augmentation techniques, they are both going to be applied to the image of interest. In your example, brightness and rotation would both happen on one image.
At the same time?
At the same time. So it might be brightened by 30% and rotated by 5 degrees on that same image. Which is why, for example, in Roboflow, you can choose to apply 5 different augmentations and produce 2 different versions per image.
So so going on the augmentation route, let's say I upload 100 images and the augmentation output number is set to 3. Will I have 300 new images at the end, or how does that work?
Yeah, so the number of how many versions per image you're getting is generally a multiplier. So let's say and it only applies to your training set as well. We actually have a video on augmentation that we'll link in the comments as well. That is a really good deep dive where Brad and I kind of talk through augmentation considerations. Augmentation only applies to your training set. So let's say your training data set, you only had 50 training images, and you could generate 3 versions for each of those 50. So you'd end up with about 150 images. Now I say about 150 images. In Roboflow, if there were duplicate images that could have been produced, we don't make them. So for example, let's say that you are creating horizontal flips. There's only, there's kind of only 2 outcomes. Either the image gets horizontal flipped or it doesn't. And so if you want to create 5 versions of horizontal flip of one image, that's mathematically limited, right? Because you can only horizontal flip an image one way, or you don't horizontal flip it. So that's where the level of uncertainty kind of gets introduced. If we say up to this many images will be produced. But yeah, that version allows you, or the number of versions allows you to increase the size of your data set by whatever multiplicative factor you choose.
Okay, that makes sense. So here's kind of a wide open one. Let's just say I've trained a model. My model isn't working the way that I want. How can I improve it? What can I do?
Wow. Okay. So on these other answers, I've been taking about a minute, and I said I want to take 30 seconds. This one would take a whole new video.
This is a course.
Yeah, this is a course. This is a great question, though. I mean, so debugging model failure. Some common things to be aware of is to think about if you have enough images represented of each of the objects you want to see. Think about if the images that you're in your test set or in your production condition are represented in the training set, because you need to have sufficient representation of all those images. Thinking about taking advantage of using active learning to improve your model, which is a fancy way of saying work with data that's actually going to best improve your model's performance. We have a video on that we can link in the comments here as well. Now, there's just like whenever there's a bug in any software, there's a lot of different potential reasons that bug could be happening, but chances are there's an answer in improving your data set. And so that's something that we try to make easy, of course, of improving and understanding the quality of your data set for your vision model.
Okay, so here's one that may kind of be in flux, but let's say, how do I build a model in Roboflow and then export my model weights?
Yeah, it's a common question. So in Roboflow, we take you from everywhere from collection to organization to annotation to training to hosting, deploying, and then doing that loop again so you can continue to improve your model. When it comes to using your model in production, it depends on how you're going to use that model for where you're going to deploy it. So you could deploy your model via API, where we can host that model for the user, and then basically in an event-based way call that model. The second way you could host a model is perhaps you want to host it in the browser, like on page load, and have a model that can run in real time on like a webcam feed.
Sounds awesome.
Yeah, or you can pass it basically any canvas element in the browser. So you could pass it like a Twitch stream, you could pass it a YouTube video, you could pass it this YouTube video. Or you can even deploy on device, right? And deploy to a smartphone or to a Raspberry Pi or NVIDIA Jetson or something like this. Now, in terms of like using your weights, if you've trained your own model from like say the models in the open source models.roboflow.com model library, you can take those weights and set up your infrastructure for any of those respective techniques. Now, we aim to actually make that be really easy for the users so they don't have to worry about kind of redundant infrastructure. And we basically carry those concerns for them. But if you want to make your own weights and then stand up your own API gateway, set up your own dependencies, set up your own environment, you could totally do that. So in general, if you want your model weights, then you should start with a model that you're going to train and be prepared to set up the production conditions from an open source model on like models.roboflow.com.
So here's another sort of more broad-reaching one, but let's say you're thinking about an application, and maybe you already have a data set. Which model is best for my data/application?
That's a good question. So I mean, there's not one model that's absolutely best for every given condition. There's not. There's trade-offs.
There's not a meta AI out there.
Yeah. There's not a meta AI. There's not even a general AI that's the best at vision, or a narrow AI that can do all vision problems the best. Models have been getting better, so generally ones that are released more recently are generally more performant. But the trade-offs, the axes of your decision, go back to the ones we mentioned earlier. The cost of basically the time of training the model and the time to do inference, the size of the model, and then the accuracy of the model. And those things kind of move and tug you in different directions, right? Like the bigger the model is, the more parameters that are included, probably the more accurate it's going to be, but also the longer it's going to take to train, and certainly the bigger it is going to be. So it's going to be tough to say deploy in smaller conditions. So those are the conditions that frame which model you should choose. Now, in terms of maybe selecting models, there's the YOLO family models, YOLO v3, v4, v5. There's object detection models that like efficient det, that's quite popular from D0 to D7. There's Detectron 2 framework. You can implement faster RCNN in TensorFlow and in Detectron and PyTorch. So you can go a lot of different directions based on where you land on your go, no-go conditions.
Definitely. So here's kind of a fun Roboflow one. So I heard there's this new feature called model-assisted labeling. Does that automatically draw bounding boxes around my object in the labeling stage? And then I just need to add labels? Or how does that work?
Model-assisted labeling accelerates your labeling workflow by using a model that you've already trained to have a first pass at labeling your images for you. And so in the best case, the model that you've already trained knows the object, draws the bounding box, and gets the class right. Now, machine learning models learn from our quality assurance and our intelligence, our human intelligence being codified in the model. So the model-assisted labeling, while it accelerates workflows, deliberately the human is going to have to make sure that the labels that the model most recently applied are correct. So the way it works is you have your data in Roboflow, you've already trained a model in Roboflow, you then have new data, and you use the model that you've already trained inside the annotation interface, and you say, select that model, and then that model will have a first pass at all of the images that you pass to it to learn and understand. And then, of course, just as I mentioned, that model is not going to be perfect, so you'll want to modify and improve the annotations.
Amazing. So I think that just about wraps it up for our Roboflow user FAQ for the day. Thanks for joining us. And of course, if you have any more questions or things that you want us to answer, feel free to leave them below in the comments and we'll include them in the next video. And of course, we'll also be paying attention as things come by day for our next FAQ video. So thanks so much for joining us. Don't forget to like and subscribe, and see you in the next video.
Thanks.